There is a YouTube video. If you Google YouTube trust and machine learning, you will find a YouTube video which is something like 1 week old. And that one goes through the main steps, the same steps that we are doing. Now in the training session, I can give you more background information. The video is something like 22 minutes, and now we have more than 3 hours to spend. So you will get more information here, but there is a YouTube video which is the core steps for the same data set that we are using. In the machine learning folder, you find a training steps text file, and there's also a presentation. And the presentation is just for introducing the data set that we are going to use. So we use 4 blocks from a bigger data set. One block, the upper left corner, that's the training data. And that has been processed to be close to nicely classified, close to the starting point where one would move to using training model. So we don't start from scratch. That something has already been done to create a training data.
Sorry, can you help me, please? I've got a problem.
In polygons. So we do have the information where we should have building proofs. And in the traditional toolset, there's a lot of capabilities for using polygons for as additional input for classification. Breaches typically end up in the ground. And when I edit the ground, I manually classify breaches. Power line wires have been automatically classified. No checking has been done, and we will see some flaws in it. But find wires is a good tool if there's systematic hits on the bigger power line wires. We can classify those automatically. And for our coding, it's a nice thing if long linear features are classified before doing the coding. Wires and fences, they connect objects. And for coding, if we have a single standing object, it becomes one proof. And everything works nicely. But if we have objects touching each other, then in our grouping, that may become one group. And then our classification can't really classify it correctly because there's 3 different objects of interest in one group. And our classification is limited by the grouping. And in Terrascan, there's a relatively new tool, classify linear pictures, which I have used to classify fences, and then I have done manual editing on that result. So those classes have been done before we start the machine learning exercise. And with the machine learning exercise, we aim to classify to 7 different classes the remaining points. There's 2 vegetation classes, vegetation and tree, And the rule is that if it's 4 meters or taller, then it's a tree. If it's less than 4 meters in height, then it's vegetation. There's a glass building structure. Anything which belongs to a building is above a building roof or right next to a building roof, we classify to a glass building structure. So for building structure, the vicinity of building roof points is the critical thing, critical criteria. Then we classify cars, and that is cars and vans, both moving and stationary. We classify poles, mostly that's light poles. And we classify machinery, and that is construction equipment, diggers, tractors, lifters. And then there's a glass structure, and that's everything else that is man-made. So the structure is a big variety of object types. So with machine learning, we do those 7 classes. And now we'll start to go through the training steps. So you start either microstates or statics, and you open from machine learning, that folder, either machine learning.spx or .dgm. The second step says that we should open point classes from mission subfolder. So you go to define classes, which is this one. Third icon in the first scan toolbox. And you open from machine learning. Mission folder, there's machine learning.ptc. And you know you have to write list of point classes when the last one in the list is 29 things. The next thing to do is that we open a project. So I have created a project called Machine Learning Train, which only has one block in it. If I have a bigger data set, I would want to have one training data block here, one training data block there, one block here, and perhaps one block there. So blocks from different environments, so that I would have different kinds of examples of objects. But now you go to define project, and you open from machine learning, and A001, machine learning train.prj. And it only has one block in it. My instructions say that we should check attributes the project is storing. So I go to edit project information. You don't have to do the same. We're not going to make any changes. We just take a look. We do have color. We will look at what the color looks like later on, but there is color extracted from vertical looking images in the point column. We do have distance, so that this is height from ground. And we do have group, so this is the training data set. We must have grouping done we must have classification done. And there's also normal vectors that have been computed. The machine learning is based on parameters that the software can compute for a group of points. So if there's an object such as 1 tree, and that has been successfully grouped as one group, maybe there's 1,820 points on the tree. The software can compute statistics about the points belonging to one group. And then the software calls one type of a statistical value, calls that a parameter. Some of the parameters require normal vectors to be computed. If we don't have normal vectors, then some of the parameters cannot be used. So typically you would want to have normal vectors computed for the machine learning capability. And that's it on the optional attributes. And it says that we should open a block and view the classification. You need to understand what the classes mean. So we have 7 classes that we work with. Vegetation, building structure, tree, car, pole, structure, machinery. First, we'll take a look at the classification that has already been done above the ground. Building roofs have been classified. And we have power line wires classified. And there are false findings here, so no editing has been done. So only an automatic process has been run on the power line wires. And we do have bridges in the data set, but in this plot we don't have any bridges. And the 4th class above the ground, which has already been done, is fence. And in this plot there's quite a lot of fences, so there's these small houses, and they are often have fences around the property. Fences can be shrub fences, so some of the fences are wide and some are more narrow. And the narrow ones are probably wooden or would be metal fences as well. But those classes have already been done. And now we start looking at the classes which we want to do with the machine learning. And in the training block, those have already been classified. Not a clean result, we need to improve the classification of the block, but there has been already an attempt to classify things into vegetation. I will keep the building roof visible class. It helps us to understand some of the features. So vegetation is vegetation which doesn't reach a height of 4 meters. Then we have a tree class, and that one is vegetation which has a height of 4 meters or higher. And there's a building structure, and the building structure should be something which is right next to building roof. So it should be above a building roof or something next to a building roof. These ones here are not really correctly classified. They're not touching a building roof. So here I can immediately see a wall in the current classification of the point cloud. And we have a pole class, and it is an air-borne data set with a vertically looking laser scanner. Most of our poles look like this, that we don't see the vertical structure of the pole. We just have some points which look like they are floating in the air, the crossbar of the lamp post. And we have a car class. So cars looking like this have been mostly classified.
The class classify automatic or manual?
Automatic and manual, so I have run test match classification. So I have done putting, I've run a test match, and then I've done some manual editing, but not complete, so that we practice the manual editing as well.
Okay, but before start machine learning, let block you need to have classified by groups.
Yeah, so to train a model, we need both grouping and careful classification done. To apply a trained model, we first need to run grouping on those blocks. And we are going to run grouping as an exercise. And there's a class called machinery. And I have a class called machinery because in our data set there happens to be a company here which rents construction equipment. So we have a lot of tractors, excavators, diggers, lifters. So we have a lot of point clouds looking like this. So this is the digging equipment, this is the shovel. Here we have something that I would also classify as machinery. It is really a truck. And this one is looks like it's a person lifter. And this looks like a small digger. But so there's different kinds of construction machinery in the data set. And then we have a class called structure. And that is anything else. I don't always really recognize what it is, but it is something which is man-made, which doesn't belong into the rest of the classes. So I don't really know what this is, but it is something man-made, maybe a container, could be a trash container. This one looks like it's a trash container. This one looks like a boat. This one, I don't know what it is, but it is so rectangular, it must be man-made, it doesn't look like an application. So structure has different kinds of objects which are man-made, which I don't believe that they belong to the classes machinery, or building structure, or car, or pole. Color is not as useful as it could be. So often I would use the color to help me separate vegetation and man-made features from each other. Here, vegetation doesn't look so green. Images have been captured at the end of April or beginning of May. Images and the laser data were not captured during the same flight. There's something like 2 weeks of time difference between the LiDAR collection and the image capture. But images have been captured when it's early spring. The deciduous trees are not with full leaves yet, and the grass is not so green. And it is good for ground penetration, that we see more of the ground. But it means that vegetation index is not so good at separating vegetation and non-vegetation from each other. If it's 2 separate flights, I would rather see that the laser data is captured early in the spring. With laser data, it's nice if we have good ground penetration and we see the ground in the forest. For images, the images would look nicer when vegetation is green, and the images would be more useful in classifying the LiDAR point cloud. So if I would decide for a case like this, I would have the LiDAR collection done at the time when it was carried out, but I would do the image collection later on. So I don't see much of a need for good ground penetration or good ground visibility in the images where LiDAR is our source for the ground model. There are some advantages in doing the image collection early, that we see more of the ground, that if we do a orthophoto, then trees do not hide so much of the ground features. But I think that is only a small benefit. But this was to explain that vegetation index is not going to be so good for us in the processing as it is on many other data sets. So we have done step number 4, and then we can start looking at the 3 blocks, which are the apply project. So the training data set has been processed further, and the apply data set is not at the same level. So you can close points, you can go to define project, and now you would open the project from the same folder, but now open the machine learning apply project. And this one has 3 blocks, and you would open one of those and look at the classification. So we do have building rules classified in the apply project. We do have bridges, but we don't have any bridge in this block. We do have power line wire, glass completed, fully automatic, and we have fences, and that is a combination of automatic and manual work. The rest of the points in the above ground are mainly in medium and high vegetation. medium and high vegetation are the stuff that we are going to try to classify with machine learning. If you look at color by group, you will see that grouping has not been done. Everything is gray color. And it is the same in the different ones. This block has some two bridges, so these were received some points which are classified as groups. So grouping has not been done on the apply project, so we also practice how to run grouping. You can now close points, and then you can go to Tools Macro, and then we take a look at the macro which does the grouping. So in machine learning macro, macro number 2 is assign groups. We open that one. So this one has 3 steps, all of which assign groups. The first one tries to find planar surfaces big enough and high enough, and then forms a group if it finds a big enough, high enough planar group of points. So some of the points get a group value in the first step. You don't have to do the same, you can just do one on my screen. But the first step has current groups setting is clear. So if there is any grouping done on classes 4 and 5 before running this step clears that grouping zeros the group values of classes 4 and 5, and then searches for planar groups. And only those points which belong to a planar group, they get a group value in this step. The next step is by tree logic, and it has current groups P, which means that if there's something which is already grouped, this ignores those points. It will only consider the points which have 0 as the group value, points which have not been grouped. And this way, my first step in the macro creates some groups, the second step creates additional groups, and the third step creates additional groups. For tree grouping to be applied, the software has to find something which has a height of at least 4 meters, and there must be at least 30 points on it. So not everything is high enough, not everything has enough points. So not all the points get a group number from the tree grouping logic. Whatever remains, then the software groups by density, or one would say groups by jump in space. So the third grouping only looks at how many points can be collected without jumping more than a given limit. Here the limit is automatic. You can also say user fixed and say that my limit is 1 meter. But here the limit is automatic. And any place where there's at least 10 points close to each other, that becomes a group. If there's some object which gives us only 7 points, it does not become a group. in our process, it's going to stay as medium and high vegetation. We need a decent number of points on a group so that we can compute some statistics, and then based on the statistics, make the decision what it is as an object. So if there's one point, it's from the point alone, it's impossible to know what is the object. Sometimes one can deduce the object by looking at the neighborhood and having some more sophisticated information about objects. But in general, we need at least a handful of points to get some useful statistics out of the group to be able to classify it. So if it's less than 10 points, it doesn't become a group, it will stay in medium and high vegetation. For now, we're going to run this grouping macro on the project. We should close points. Then you can go to define project and go to tools, macro, and remove if you have a macro in the list, and add the macro from machine learning, and macro number 2, assign groups. And we use 20 meters of neighbors, and we use write over original, and we don't run using TeraBatch. And it's not going to take that long. We don't need to speed it up, and things are a little bit simpler when we don't involve TeraBatch. So we are running a macro on all blocks. Macro is macro number 2, neighbors is 20, save point is write over original, and run using TeraBatch is 4. And you click OK. And we are going to complete also step number 7, and then we'll take a lunch break.
One question, sorry. When you click that option to use neighbor 20 meters, he's still processing the blocks separately, but he's looking 20 meters more than the block.
Yeah, so I'll show what it means. So when I open a block, I can do the same, but I can say that I want 20 meters of neighbors. And then the software is going to read the active block, and then anything from the neighboring blocks that is inside the highlighted polygon. So it first reads the active points, then it reads from the neighboring blocks. I'll switch all classes on. And the software knows that 13.591 million points came from the active block, and 815,000 points came from the neighboring blocks.
So it will be saved separately.
Yeah, so
My block will be my blocks with same number of points.
Yeah, so when I save points at the end, it only saves the active block points. It doesn't modify the neighboring blocks.
That's perfect.
So the reference data helps us to make better decisions at the border. So many of the operations the software uses to make a decision on one point, it uses points close by. And if the data ends, then we have incomplete information and the decisions are not as good as they are when neighbors are loaded. So for many of the macros that we run, the result is better when neighbors are loaded.
Thank you.
And when we run a macro which creates groups, we get a side result in the folder, we get small text files. So we executed a macro which assigns groups. We have executed on 3 blocks. We get 3 text files. I'm going to use inspect point. You don't have to do the same. But I'm just showing you the group values that we have. So we can see that there's 2 cars here, which are partially inside one block, and part of the car is inside another block. And for each block in the project definition, we have reserved a number of group values, in this case 1 million group values for each block. So when the software runs grouping for the block where my mouse is, it assigns group numbers which are 181 million and something. When it runs grouping on the block that my mouse is inside now, the software has used group numbers 169 million and something. And now all the groups in this block are 169 million and something, and all the groups in this block are 181 million and something. And in the assigned groups, there is nothing that would make the group numbering match at the border. It would be a very hard thing to implement, as we can run the grouping with multiple instances in TerraPatch. The solution in the software is that the grouping writes a small text file, some information about the groups, which are inside more than one block. And then we run a second macro, fixed border groups action, and it has to be run as a separate execution. So it can only be run when all blocks have been grouped. So I can't run it as a second macro in the same process. I can't put that action into the same macro. So the first macro execution has to be completed, and then we need to run a second macro execution with the fixed border groups. So if you have any points loaded, I want you to close. Then I want you to go to Tools and Run Macro, and you remove and you add fixed border groups macro. And when running the fixed border groups, you should use the same neighbors setting as you use when assigning groups. And this also is something that can be run with TerraPatch. This goes very fast, and we have a tiny little project, so we have no need to use TerraPatch. And you click OK. And this doesn't quite manage to fix 100% the cases, but most of the cases it manages to fix. And so now, if I look with inspect point, now I have the is on this car, and the same on this car. All the other objects in this more northerly block, all the other objects, they have group numbers 181 million and something. It is part of the project definition how many groups we reserve per block. 1 million is more than is needed. That these blocks typically have something like 10,000 groups. But our project definition has a number range of group values reserved for every block. So now we have completed step number 7, and we can take a break.